Hello, everyone. For our project, we created a rule based interpreter system for a game I'm sure you're all familiar with, the card game called Uno. So, to start, what even is an interpreter? An interpreter is a program that executes code line by line without needing to compile it first. Think of Python itself. That's an interpreter system. Interpreters are vital for more modern programming. They allow interactive coding, rapid debugging, and portability across different platforms because they read and execute one instruction at a time. They are perfect for dynamic rule based systems. For this project, we applied these concepts to build an interpreter that acts as a referee for a game of Uno. Our program reads commands from players like play red 5 or draw. It then checks if that move is legal, according to the rules of Uno. If it is, it updates the game state and moves on to the next player. We chose this topic because it's a fun and engaging way to demonstrate core interpreter concepts like tokenization, parsing, and execution. Instead of abhorring and abstract language, we're applying these principles to a familiar and rule rich game. So, to make our interpreter work, we first had to design a simple mini language for the players. The goal was to be concise, clear, and formalize UNO actions into text commands. On this slide, you can see the core grammar, and it's quite simple. So, to play a number card, you type play color number. So, in this case, play red 5, or it could be play yellow 5, play blue 0, generally those are how it goes. Next, to play an action card, you type play color and then the action card. So in this case, play blue draw 2. There's also play blue reverse, play green skip, all those sort of things. So that's how you play that. To draw a card, you just type draw, and this is automated so that if you're the receiving end of a draw 4 or draw 2, you automatically draw that many cards. So automation, let's go. And then to set the color after a wild or a draw 4, you type in wild green or wild blue, wild color essentially. All right, so that's pretty much the input language. Let's move on to the language rules. All right, so now we go into the language rules. The interpreter's most important job is to validate these commands, and it checks for three things. Valid tokens. Does it recognize the word? So it needs to exist within the bounds of the game for it to recognize the command. So let's say purple isn't a color in Uno, so play purple 7 would be an error because there's no purple. Next, valid syntax. Is the command in the right order? So play 7 red would be an error because it would be play red 7 instead. So yeah, it needs to be in the proper order for it to work. And then finally, it needs to be a valid game move, and it checks for that too. Is the command legal right now? Trying to play red 7 on top of a blue 2 would be an invalid move error. So yeah. Next, we're going to go into system design. Our system is built in Python and has a modular design, which was key for the project. The entire process is a pipeline broken into three main components: the lexer, the parser, and the executor. We're proud to say that we built this using only built-in Python libraries like RE for regular expressions and data classes for our card and player objects. So, yeah. Here's what each part of the pipeline does. The lexer, or the tokenizer, is the first step, and it takes the raw text, like say play blue 5, and breaks it into a list of tokens. So in this case, the action is play, the color is blue, and the number is 5. Next is the parser. This part that takes that list of tokens and checks if the grammar is correct. If it is, it groups the tokens into a structured command like play command object. If the syntax is wrong, it throws a parse error. And finally, we have the executor. This is the game engine, and it takes the valid command from the parser and applies all of the Uno rules. It checks if the move is legal, and it updates the player's hand. Also, it changes the top card, and it even handles moving on to the next player. So, yeah, those are the system components.
Now for section 4, this text diagram shows the complete data flow. The user string command comes in, goes to the Alexer to become tokens, to the parser to become a structured command object, and finally to the executor, which updates the central game state and sends a message back. This separation of concerns was our most important design choice. It allowed us to unit test each part independently. We also made other key decisions. We handwrote our parser. Since our grammar is simple, it starts with play, draw, or wild, and we didn't need a complex library. The Lexer is case insensitive to make it user friendly, and finally, the executor's state transitions are atomic. This means a move either fully succeeds or fully fails. The game state can never be left in a half finished or broken state. Alright, now let's dive into the implementation in section 5. The very first thing we did was define our custom error classes, Lexer error, parse error, and invalid move error. This was crucial for our separation of concerns design, because it means our Lexer can just raise a Lexer error if it sees an unknown word like purple, and our parser can raise a parse error for bad syntax like play 7 red. Our game engine can raise an invalid move error if a move breaks the rules, like playing a red 7 on a blue 2. This keeps our error handling clean and specific. Next, we define our core data structures using addData class. You can see the card class which just holds a color and a value, and a simple player class which just holds a name. We also wrote the build simple deck function. This is just a helper that loops through all the colors and values to create our 60 card deck and then calls random shuffle. We also have a reshuffle from discard function that handles the important logic of when the draw pile runs out. Now this right here is the heart of the entire program, the game state class. When we initialize it, it takes the list of players and builds everything else. You can see it creates the hands as a dictionary, it calls build simple deck to create the deck, and it sets the current player to 0 and direction to 1, which means clockwise. And most importantly, it tracks the special states, like the pending draw which is 0 to start, and awaiting wild player which is none. The init method finishes by calling new initial hands and init top card to get the game ready to play. Now for the first part of our pipeline, the lex function, this function takes the raw command string like playRed5 and it splits the string by white space and loops over each part. We normalize it to uppercase and we then just use a series of if statements and then checks against our predefined sets for actions, colors, and specials. It has one special case for the word wild, and if wild is the first word, it's an action. If it's the second word, as in play wild, it's a special card. If it recognizes a word, it appends a token, tuple like token action play. If it gets to the end of the loop and hasn't recognized the word, it raises that Lexer error we defined earlier. The list of tokens from the Lexer is then fed into our parse function. This function's job is to check the grammar and convert the tokens into a structured command object. First, it checks the action, and if the action is draw, it's simple. It checks that there's only one token and returns a draw command object. If the action is play, it's more complex. It checks the second token, and if it's a caller, it expects a third token for the value and returns a play command with the caller and value. If the second token is special and the value is wild or draw 4, it returns a play command with the caller set to none. Anything else like play red with no value is a parse error. And finally, we have the execute command function, our game engine. It takes the game state, the player ID, and the command object from the parser. The very first thing it does is validate the state. It checks if the awaiting wild player is set to this player's ID. If it is and the command isn't a wild set command, it immediately raises an invalid move error. This is our two-step wild rule in action. If the state is normal, it checks the command type. If it is a draw command, it checks if pending draw is greater than 0. If it is the player draws that many cards and the penalty is cleared. If not, they just draw one card. If it's a wild set command, it's straightforward. It sets the color on the top card and sets awaiting wild player back to none, and calls our advanced index helper function to change the turn. The most complex part is handling a play command. First, it finds the card in the player's hand, then it checks the legality. You can see the logic here. If pending draw is active, it only allows another draw 2 or draw 4. Otherwise, it checks for a wild card or a match in color or value. If the move is legal, the card is popped from the hand and added to the discard. Crucially, it checks for a win condition right here, before any effects are applied. Finally, it applies a card's effect like setting a waiting wild player for a wild, adding the pending draw for a draw 2, or calling advanced index, sometimes with steps equal to 2 for a skip, to change the turn.
To prove our system works, we wrote a comprehensive test script. We didn't just play the game, we created a controlled, predictable game state for a player named Alice. We set the top card to be red 1 and gave Alice a specific hand with a red 7, a blue 5, and a wild card. We then ran a series of valid tests. First is play red 7. It passes because the color match. Next is play wild, and it passes also, and correctly puts the game into an awaiting color state. And after that, we input it with wild green, and it also passes. And it sets the color and advances the turn. More importantly, we ran invalid tests. First is we tried to play yellow 5, which Alice doesn't have. It fell with an invalid move error. We tried play red 7 on a yellow 1. It failed because the card didn't match. We tested syntax errors like the typo play red 7. It spells like PLYA instead of normal PLAY, which gives it elixir error, and play red, which gives a parse error. We also confirmed that trying to play a normal card when draw 2 penalty was active was incorrectly blocked. This test confirmed that our interpreter not only correct, but also robust against all types of user error.
The core interpreter is text-based, but we wanted to make it a real playable project. So we built a full graphical user interface inside Google Colab. It starts with a setup screen where you enter the players' names, then it loads the main game screen. This UI is fully reactive, and it's connected to our Python GameState object using Colab callbacks. The UI shows the current player, the top card, and a Show My Hand button. When you click it, it reveals your cards as actual images. When you type a command like play red 6 and hit go, the JavaScript finds the card in your hand and triggers a CSS animation, making the card fly to the discard pile. The next part of this demo will be a video of our group demonstrating the gameplay of our project.
Hello. Today we'll be this demoing our Uno game. So this is our Uno game. These are the explanations, but for now we'll just run it so that we can demo the game. So oh well, this is the executor. So we have to go. Okay, so first we're gonna have to start the game. So since we have three players, we're gonna input three. So Sophia, Gian, Darren. All right, so we'll play. First we'll add this. So we'll have to run this next cell in order for it to work. So yeah. So it's gonna be Sophia's turn for now. We'll show the hands. There you go. Sophia, what do you want to play in this scenario?
Um, I'll go for wild card.
Wild card. Hey, wild. What color?
Um, Color. Let's go with blue.
Um, wild blue. All right, Gia, it's your turn.
I'll go with play blue 3.
Blue three. Play blue three. All right, it's Darren's turn. Show hand.
Okay, a blue 4.
Blue four. Play blue four. All right, it is Sophia's turn.
Blue reverse.
Blue reverse. Okay. Play blue reverse. All right. It is Darren's turn again.
Okay, now let's go with the draw 4.
Okay. Play, draw 4. All right. It is. Oh, wild card. Wild,
Okay, let's go with red.
wild red. All right. Now it is Gian's turn. Are you gonna draw? Draw. I'm assuming that's the play
Since
here.
I have a draw to run draw part, only thing I can do is to draw. So I need to draw.
Okay. All right, Sophia, it's your turn.
I'll go with 8. Red 8. Draw. I'll go with red 8.
Red 8. There you go. Darren's turn.
Let's go with blue 8.
Blue 8. Play blue 8. Play blue 8. All right, now it's Gian's turn.
I'll go with the wild card,
Wild card. What color?
color green.
Wild green. All right, it's Sophia's turn.
I'm going for I'll go with the draw 4. Draw 4.
All right. Play draw 4. What color?
Red.
Red. All right, now it is Darren's turn.
Okay, I'm gonna play a draw 2.
Oh, that you can stack those? Play draw
Yes.
2. Okay. Oh,
I know, it's supposed to be played red draw 2.
red draw. There you go. All right. Gian, is your turn.
The only thing I can do now is to draw. So I'll just draw.
So, all right. Sophia, is your turn.
I'll go with
Play
0. 0.
red 0. All right. So, Darren, is your turn.
Okay, maybe let's go with a green 0.
Green 0. Show my hand.
I'll go with the green skip.
Green skip. Play green skip. Show hand. Play yellow
Okay,
skip.
maybe yellow skip.
Skip. All right. Sophia, it's your turn.
I'll go with I'll draw. I'll draw. Just
Draw.
draw.
Okay. There you go.
Okay, so I don't have anything left to
So
this
draw.
candidate, then draw.
All right. Back to you. Gian?
You're yellow nine.
Sorry, what was that? You're a bit choppy.
Hello, can you hear me?
I can hear you now.
I'll play yellow 9.
Yellow 9. Play yellow 9. All right, Sophia, it's your turn.
I will be playing I think I'll go with play yellow 8.
Hello. All right, Darren, it's your turn.
Okay, simply draw.
All right, Gian, it's your turn.
Do yellow for
Uh, Sophia, it's your turn.
Draw.
Draw. All right, Darren, it's your turn.
I'm gonna also draw.
Draw. All right, Gian, it's your turn.
I'll play yellow one.
Yellow one. Oh wait, sorry. Play yellow one. All right, Sophia, it's your turn.
I'll have yellow yellow 5.
Play yellow five. All right, Darren, it's your turn. Ooh, draw four.
Yeah, I'm gonna go with that.
Okay, draw four. What color?
Let's go with red.
Red. Ah, wild red. There you go. Gian, what do you want to play? I'm assuming you have to draw.
Draw. Yeah, I'll have to draw.
Got it. So, all right.
Right. I will
Sophia.
be I think I will I'll I'll go with with I might go with I'll have a red skip.
Red skip. All right, Gian, it's your turn. You want to do a red reverse?
Since we already demonstrated all the cards, draw four and the other cards, I'll just do a normal number card so Sophia will win. So I'll do play red five.
Play red five. All right, Sophia, it's your turn.
All right. I don't know if this is allowed, but I'll just go with the owner right now. So like wild card, and the color will be blue.
Play
Play wild card blue.
wild.
Play
Wild.
wild.
Cool. Okay. Are you
Uno.
guys sure we got the reverse there? Wait. Oh, there we go.
I think we use all of the cards though, Adam. So I don't think that's
All
enough.
right, so that's the
Already
game.
used up cards.
Yeah, so this is the general instructions, and yeah. Oh yeah.
Okay.
We also added a few key features to improve gameplay. First is game end detection. The executor automatically checks if the player's hand is empty. When it is, it stops the game and displays a winner screen, enlisting the runner-ups as well. Next is hidden hands. This was a simple but crucial feature. By default, the hand is hidden. The game will say, pass the laptop to Alice. Alice can then click show my hand. This prevents other players from seeing your cards. And next is the graphics and animation. As mentioned, using real card images and CSS animation makes the project feel polished and genuinely fun to play.
So to conclude, what did we learn? The main takeaway was the power of a modular design, separating our code into a lexer, parser, and executor, which was key to managing the game's complex rules. Our project's strengths are its robustness in handling errors, its maintainable code, and the polished user experience from the HTML interface. Now, the main limitations are that we used the stacking house rule. We're missing the official challenge rule for draw force, and we used a simplified deck for testing. For future improvements, we would first add the challenge rule, then look into creating AI opponents, and finally add the classic Uno rule. And here are the references we used for our initial research on interpreter systems. As noted in our report, we did use generative AI as a tool during development, and we use it to brainstorm the initial lexer/parser pattern and to help structure the complex if-else logic for the executor. In our Python notebook, we explained how this AI-generated code served as a starting point, which we then personally refactored, debugged, and integrated into our own modular game state system to build our final project. This marks the end of our video demonstration. Once again, I am Gian, and this was our Uno Python Interpreter project. Thank you so much for watching.